To this point, we've been talking about polynomial functions and polynomial equations. So this lesson is about talking about polynomial inequalities. When we're dealing with a polynomial inequality, a lot of the things that we've done so far with polynomial equations are involved, but there's a few more steps. Ideally, what we're trying to do is solve a polynomial inequality. So what we have is a greater than or less than or greater than or equal to or less than or equal to sign. We do this by using this location theorem. So the location theorem says this. Suppose that a function f is continuous on an interval I that contains the numbers a and b. If f of a and f of b have opposite signs, then the graph of f has at least one zero between a and b. This location theorem is essentially a version of what we call the intermediate value theorem. But generally the idea is this. If I look at a graph and I look at some interval over that graph, so a to b, if the y value on one end is, say, negative, so I get a point down here, so this would be f of a, and the y value on the other end is positive, so say up here, so that's f of b, so that basically we're saying they have opposite signs, and my function, the other key to this is my function is continuous, which means it's all one solid piece between them, then my graph has to cross the x-axis at least once. So this point right here would be my x-intercept, which means it's a 0. So that's really what this location theorem says. You can read this location theorem another way, in that if my function is above the x-axis, okay, then it's always going to be above the x-axis. In that, if I look at it between two x-intercepts, okay, say here's an x-intercept and here's an x-intercept. If these are the only two x-intercepts I have, then my function shouldn't change sign between them, which means my function is either always above, or in reverse, my function is always below. So this is the kind of idea of what we're going to use to solve these polynomial inequalities. Okay, we can use the idea of different y values with different signs to help us find zeros, but we could also use zeros to help us find the sign of a polynomial. Between two zeros, my function should always have the same sign, either always positive or always negative. If it has to change sign from positive to negative, then there has to be at least one zero between them. If there's no zero between them, it can't change the sign. Okay, so we need to solve a polynomial inequality. To do so, we will follow these steps. The first step is a step you should be familiar with doing for a lot of different things in algebra. If you're looking at a polynomial inequality, one key to this is to make one side equal to 0. So put 0 on one side of the inequality and everything else goes to the other side. It doesn't matter which side you work with. Okay? The key to that is, what we're saying is that we have a polynomial that's either greater than 0 or less than 0, because 0 is on the one side. And if something is greater than 0 or less than 0, you're basically saying this thing is positive or this thing is negative. So make one side of your inequality 0. The next thing we're going to do is essentially find the zeros of the polynomial. How do you do that? Factor the polynomial if possible, and determine where the polynomial zeros are. So if we have one side greater than or equal to 0, if we have some polynomial f of x, say greater than or less than 0, we're trying to find the solutions for which the polynomial is greater than 0. Well, in these two steps here, we're going to figure out where is the polynomial equal to 0. Well, if we figure out where the polynomial is equal to 0, then that means everywhere else it's either greater than 0 or less than 0, and we're going to be looking for the greater than 0 ones. Then, once we find the zeros, we're going to graph those zeros on a number line to essentially divvy the number line up into a bunch of intervals. These intervals will allow us to gain some test points. Those test points will then determine which intervals satisfy the inequality. Final step, write your answer in interval notation. The best thing to do is, I think, to see this in practice. So here is a polynomial inequality. We need to solve this polynomial inequality. So first thing is make sure it's equal to 0. So what I'm going to do is I'm going to add this 7x squared to both sides. So I'm going to get 2x cubed plus 7x squared minus 15x is less than or equal to 0. So if I'm going to try and solve this polynomial inequality, I need to find all x's that make 2x cubed plus 7x squared minus 15x less than or equal to 0. Okay, so what x's can I plug in here that will give me a negative number or 0 is essentially what I'm trying to find. So the first thing we're going to do is find the zeros of 2x cubed plus 7x squared minus 15x. How do you do that? Set it equal to 0 and solve. Well, it's a polynomial equation. Solve a polynomial equation primarily by factoring. Can this be factored? Well, yeah, I can pull an x out of the whole thing. I get 2x squared plus 7x minus 15 equals 0. I can factor it some more because it's a quadratic. And I get 2x and x. I'm going to need to get a 5 and a negative 3. So now I get my 2x squared from here. I get my negative 15 from here. Then the insides and the outsides will get me my 7x. So my zeros are x equals 0, x equals 3/2, and x equals negative 5. So that's where my function is equal to 0, which is somewhat of what I was looking for, right? I'm trying to figure out where is my function less than or equal to 0. Well, these are where it's equal to 0, so these are some of my solutions, but there's still more, because now I have to figure out where it's less than 0. So the next thing you're going to do is set up a number line. Place these values that you just found on the number line. So here's negative 5, here's 0, here's 3/2. It doesn't have to be very accurate. What you just did is you divvied your number line up into 4 intervals. Okay? This would be interval 1, this would be interval 2, this would be interval 3, this would be interval 4. Okay? In these intervals, my polynomial will either be positive or negative, because we've already determined where my polynomial is 0. It's 0 at these 3 places. So the only other possibilities are that it's positive or negative. If you look at a value, a number can have one of 3 values: positive, negative, or 0. So now we've basically eliminated where it's equal to 0, and we're going to then figure out where it's positive and negative. So what I'm going to do, and there's 2 ways to do this. One thing I can do is I can take some number from this interval, negative 6. I can plug it in to the inequality and see whether it makes this polynomial positive or negative. Then I'm going to take another number, negative 1, from this interval, plug it in, see if it makes the polynomial positive or negative. Keep going, 1, 2, and plug these checkpoints in and see what kind of answer I'm going to get. So if I look at this and say my function is 2x cubed plus 7x squared minus 15x, and I want to find f of negative 6, I go 2 times negative 6 cubed plus 7 times negative 6 squared minus 15 times negative 6. Now you do that, and that computation is going to be not the greatest. I mean, if you have a calculator, it's not too bad. But what I could also do is that this right here is the factored form of that polynomial. So I could plug it in there too. In that case, I get negative 6 times 2 times negative 6 minus 3 times negative 6 plus 5. So I get negative 6 times, this will be negative 12 minus 3 is negative 15, and negative 6 plus 5 is negative 1. And in this case, it doesn't matter what answer I get. What I'm concerned with is, am I getting a positive answer or a negative answer? If negative 6 gives me a negative answer, every number in this interval will give me a negative answer. Because between all my zeros, my function cannot change sign. If it does change sign, then I should have another 0, but I don't. These are the only zeros I found. So there's no 0 in this interval, which means this interval should contain all the same sign. So if I look at this, negative 6, negative 15, negative 1. Negative times negative gives me a negative value. So negative 6, when I plug it in, gives me a negative value. What value it is exactly is really not that important. The fact that it's negative is the important part. So when I plug negative 6 into my polynomial, I get a negative value. What was I looking for? I was looking for my polynomial to be less than 0. So that's something I was looking for. Go to the next one, the next one, the next one, and see what happens. So I want to find f of negative 1. Again, all I'm concerned with is, do I get a positive or negative answer? I could plug it back into this function up here, but I like plugging it into the factored form. It's faster. So I get negative 1 times 2 times negative 1 minus 3, and then that's going to be multiplied by, I'm running out of room here, negative 1 plus 5. So I get negative 1, this is going to give me a negative 5, and this is going to give me a positive 4. Negative, negative, positive, I get a positive value. Okay? Keep going. Let's make some room. F of 1 is 1 times 2 minus 3 times 1 plus 5. So 1 times negative 1 times 6. Positive, negative, positive is a negative. And if I do it for 2, f of 2, I get 2 times 4 minus 3 times 7. So 2 times 1 times 7, positive. What you don't want to do is just say, well, look, they're alternating sign, negative, positive, negative, positive. And say, alright, well, if the first one's negative, then I can just fill in the rest from there. That's not necessarily the case. You may get 2 positives, you may get 2 negatives, so look at that. So what am I doing now? What I'm doing is saying, well, what's my answer? Well, I wanted to know where my polynomial was less than or equal to 0. Where is it negative or 0? Well, it's negative here, and it's 0 at these values. So now I need to write that down in interval notation. So if I write that down in interval notation, let's make some room. Erase. I'm going to say that I want my solution to be negative infinity to negative 5. I want to include negative 5. You never include infinity, so I put parentheses. And I want to union that interval with the interval from 0 to 3/2. But I also want to include 0 and include 3/2. Bracket means you included, parentheses means you don't. So this would be the interval solution to the inequality. These are the intervals where this polynomial is less than or equal to 0. Now there's another way I could have done this. Another way I could have done this would be to think about the graph. So let me get a different color. Alright, so what do we know? This polynomial here. What I know is that when I have this polynomial here, if I was to graph this polynomial, this right here would determine what happens at the ends of the graph. It's an odd power and a positive coefficient, which means on this end I'm pointing up, and on this end I'm pointing down. The zeros I got all have odd multiplicity, which means, because they all have multiplicity of 1, which means I should cut through the x-axis in each case. Well, if I'm down on this end and I cut through the x-axis, I'd go above. Then I come in down, I cut through, and I cut through. Well, if I'm below the x-axis, if I think about this number line really as the x-axis, okay? If I'm below the x-axis, my function is negative. If I'm above the x-axis, my function's positive. Below the x-axis, I'm negative. Above the x-axis, I'm positive. I like that method of doing it because you don't have to plug numbers in and get an answer, plug numbers in and get an answer like we were doing. And it makes it go much faster. But you got to know some of those other things we've already talked about, like leading coefficient test and the idea of repeated zeros. Either way you want to do it, the solution should always be written in interval notation, and that would be the solution here. All right, that got kind of messy, so let's do another one. All right, here we go. Solve this polynomial inequality. First thing, make sure it's 0 on one side. You already got it, so that's done. Next thing you want to start to do is find the zeros for this polynomial. So figure out where the zeros are for x cubed minus 2x squared minus 5x plus 6. So you're solving this equation. This equation helps you solve this inequality. But remember, what are we looking for here? We're trying to make this polynomial greater than 0. So the solution should be all the x's when I plug them in that make this thing positive. Alright, but first we're going to find the zeros. So it's a polynomial equation. The way you find the zeros is you have to factor. Now the last one we factored by hand. I pulled out a common factor. I did my quadratic factoring. This one you might not be able to do that. This one you may not be able to do that. So how else can you factor? Well, you could use division. So let's do some synthetic division. 1, negative 2, negative 5, 6. Put a 1 out here, see if that works. Put a 2, see if that works. Remember, take factors of your constant divided by factors of your leading coefficient. 1, 2, 3, 6. That's factors of 6 divided by 1, so I get 1, 2, 3, and 6. And I can use positives and negatives. So I bring this first one down here. Multiply, put it here, negative 1, add straight down, keep going, negative 1, negative 6, negative 6, 0, got one that works. So that tells me I can start factoring by x minus 1, and the other factor is x squared minus x minus 6. Remember, we're trying to solve this equation. Keep factoring as far as you can. X minus 1. This next one's going to be x minus x plus 2, x minus 3. I can do this one by hand because it's already a quadratic. Second I get down to a quadratic, I don't have to do division. So what are my zeros? 1, negative 2, and 3. So I'm going to graph those on a number line. Okay, I get negative 2, 1, 3. The multiplicity for each one of these zeros is 1. Odd multiplicity. Okay, which means I should cut through the x-axis for each one of these zeros. If I think of it like their x-axis, x-intercepts. Alright, think about your graph. If I look at the graph of this thing, cube, positive coefficient, on this end I'm pointing up, and on this end I'm pointing down. This x-intercept's odd, so if I'm down, I have to cut through the x-axis, now I'm above. Come to this x-intercept, I have to cut through, now I'm below. Come to this x-intercept, cut through, and now I'm above. So what I have are intervals. In these intervals, my graph is negative, positive, negative, and positive. Why? Because it's below the x-axis in this one, above the x-axis, below the x-axis, above the x-axis. Which means my y values are negative in the first one, my y values are positive in the second one, and so on. So now that you have this set up, look at what you're trying to find. I'm trying to solve this inequality. I want to know when the polynomial is greater than 0. Greater than 0 means positive, so it's positive here, and it's positive here. What happens is, at these values, my polynomial is equal to 0. Do I want this polynomial equal to 0? No, so I don't want to include these values in my solution. So when I write my answer, don't include negative 2, 1, or 3. But I want the interval from negative 2 to 1, and I want the interval from 3 to infinity. but I don't want to include any of these values. So I use parentheses. There's my solution. Okay? Again, if you don't like that method of doing it, what you can do is I can say, all right, let's take some number in this interval, say -3. I'll plug it into this function and see what kind of answer I get. Take another one in this interval, say 0. I'll plug it into this function, see what I get. 2, 4, here's some numbers you can try. And this is just a matter of plugging numbers in and seeing what you get. That's far more time consuming than using a lot of the things we've talked about so far. So that's how you solve polynomial inequalities. Remember, it's not always going to be minus plus, minus plus, minus plus. Sometimes you get 2 pluses, sometimes you get 2 minuses. That'll be mainly when you have an even multiplicity. So when you have an even multiplicity, you'll have the same sign on either side. Odd multiplicity, you have different signs.